Welcome everyone. In this video, we'll be talking about the basic concept of biostatistics. My name is Andy Ken William Udofia. So let's get right into it. Now, what's biostatistics? Biostatistics comes from two words, right? Bio and statistics. So, biostatistics is a branch of statistics that deals with the collection, organization, analysis, and interpretation of data related to the living organisms and health. Now, the first part of this description talks about statistics, which is it is a branch of statistics that deal with collection, organization, interpretation of data. Now, the second part, which is the living organism and the health, is now the bio part of it. So basically, statistic is the collection, organization, analysis, and interpretation of data. Now, biostatistics is how it relates to living organisms and health. Now, why is biostatistics important in nursing and healthcare? It's used in evidence based practices, in research, clinical decision making, public health. Now, you know that evidence based practices in nursing care and other health sciences is very, very important. We don't just speculate facts, we use actual data to come up with facts which we practice with. So, how do we get this data? It's through biostatistics and the tools of biostatistics. The same thing in research, in also making clinical decisions. For example, the effectiveness of a drug, right? We don't just speculate that, we use actual data to get this into place. Now, another example, the examples of biostatistics in practice is comparing two drugs. That's comparing the effectiveness of two drugs in a particular population. You use the data, right? You get the data that this worked well. We're comparing two drugs to see its effectiveness. And also in monitoring disease trends. This is very common, from time to time you hear that, okay, we have so number of um, diabetes in the United States. This is the number of stroke in the whole world. How do they get this data? It's through biostatistics and also evaluating patient outcome. These are the examples of biostatistics in practice. Now, there are two types of statistics actually. We have the descriptive and the inferential. Now, what is the descriptive? Descriptive is just as the word sounds, it describes, summarizes, it gives you a summary of your data in forms of tables, graphs, and averages. This is where you have the mean, median, mode. Descriptive, we're just describing the data. We are not drawing any conclusion, right? We are just describing. Meanwhile, in inferential, we are drawing conclusion. Take note of the difference. In descriptive, we're just describing, right? But in inferential, we are drawing conclusions. We are making predictions and we use the samples. Now, data, we've been talking more about data. What is data? Data are facts, figures, or observation collected for analysis. In the nursing field, we take data, right? In our assessment, data collection is like one of the important part of data collection, and it adds to this biostatistics. So don't let data get strange to you. Now, what are the types of data? We have the qualitative and the quantitative. As the word sounds, qualitative, you're describing, and then quantitative is numbers, talking about numerical values like 1, 2, 3. Qualitative, maybe the color of hair and other descriptive data. Then variables and constants. Now, variable, as the word sounds, can change. Meanwhile, constants remain the same. And we'll show you in an example. Variable is a characteristic that can change while a constant remains the same. What are the examples of a variable and constant? You have age, Your age can change. Actually, your age should change with time. Your blood pressure, your weight, all of those are variables because they can change. But the constant thing is your gender. Your gender does not change. And then your blood group. Now, population. So we're just talking about the key terms in um, biostatistics. Population refers to the whole group to be studied. For example, you want to use the height of all the students in your school. That's the population. Now, taking the analysis of the whole population is known as census. Take note of that. So, population refers to the whole group being studied. Meanwhile, sample is a subset of a population. Why do we need a sample? Because sometimes it is impossible to go with the population. Maybe it's too large. You don't have enough resources to do that to get the whole population. You can pick out a sample in a way that it represents the population. So now we have scales of measurement. We have four: nominal, ordinal, interval, and ratio. What is a nominal scale? It's their nominal data are categorized without order, such as blood group or gender. There is no category, like it's not in a certain hierarchy. You're just categorizing them. You have male, female. None is higher than the other one. Blood group A, AB, none is higher, right? But in ordinal scale, ordinal has order. That means from highest to lowest. But the difference between the categories are not equal. Example, pain severity. You have mild, you have very severe, you have severe. These are different ordinal stages, right? But what take note that the differences between the categories is not equal. Example, education level, learned, medium, moderate, right? Patient satisfaction, disease, disease stage. All of these are ordinal scales. Now, when you're talking about the interval scale, interval scales have equal spacing between values, but no true zero, such as temperature. What do we mean by this? Even if you have zero as the value of your temperature, it doesn't mean that there is no temperature, right? Even if you have zero, it's just a value, but it does not mean that there's no temperature because you are at 0 Celsius. But now, on the other hand, ratio scale has equal spacing, but a true zero value, such as weight. If you have zero as your weight, that means you do not have any weight. If you have zero as your height, that means you do not have any height. You take note of the difference. In interval scale, there is no true zero. Example, the temperature. Even if you have zero, it doesn't mean that there's no temperature. But if you have a zero in a ratio scale, it means what it means there is nothing. So that's the difference between the interval scale and the ratio scale. So now we just summarize what we've gone through. We talked about the meaning of biostatistics, that it deals with handling data as it relates to living organism and healthcare. Now, the types of statistics, we talked about the descriptive, which is just presenting the data, and inferential, which deals with drawing conclusion. Talked about the types of data, which is the qualitative and the quantitative. And also we talked about the variables and the constants. Variables can change, like your age, your blood pressure, but constants do not change, like your gender and your blood group. We talked about what a population is. What is a population? Is all the data to be analyzed. Now, sample is a subset of a population. We talked about the scales of measurement. What are the scales of measurement? The nominal, the ordinal, the interval, and the ratio scale. And with that, we get the basic concept of biostatistics.